Basic Math, Assessment 1, Review 1, Questions 1 through 3. Question 1 reads, find the following sum. So we'll follow over to the far right-hand side of these numbers that have already been stacked based on place values, and we'll sum the first column down. We have a 6, plus a 9, plus a 7 to make a 28. We'll record the 8 below that column and carry the 2 to the next column. We now have a 2 plus a 2 plus a 4 plus a 5 plus an 8. This makes 21. We'll keep the 1 and carry the 2 to the next column. We now sum down 2 plus 1 plus 2 plus 6 plus 2 to make 13. We'll place the 3 and carry the 1 from the 13 to the next column. We now have 1 plus 3 plus 3 plus 8 plus 8 to make 23. Again, record the 3 and carry the 2 to the next column. We now have a 2 plus a 7 plus a 3 plus a 6 plus a 6 to make 24. We'll keep the 4 and carry the 2 to the next column. In the next column, you'll see that we have blanks when we begin to add down. We have a 2 plus a 7 with a blank, plus a 4. We treat those blanks as zeros. So this is 2 plus 7 plus 0 plus 0 plus 4 to make 13. We now return and place our commas in between where our periods would be, so that our final answer is 1,343,318. In question number 2, you're told to use the rules of order of operations to evaluate the following expression. Write the solution as a mixed number or a fraction in the lowest terms. If you recall, your order of operations has 4 steps. In step 1, you're to clear all grouping symbols. This means braces, brackets, parentheses, and such. In step 2, you're to complete any exponents you may find, as well as any radical expressions. In step 3, you're to complete multiplication, following from the left to the right. Finally, with step 4, you're to complete addition and subtraction, following left to right. So, if we go back to step 1, it says to complete any grouping symbols. We have a pair of parentheses in the front and a pair in the back. The pair of parentheses in the front does have something to complete mathematically. The parentheses in the back are simply holding the constant and the fraction together with its exponent. It has nothing mathematically to complete inside the parentheses. So we'll go back to the first pair. We have a 2/5 plus a 2/5. These already have like denominators, so we can go ahead and sum them across. I have a 2 plus a 2 to make a 4. Then keep the denominator, the 5. I then come back here and will copy down everything else behind it. I have a dividing symbol, so division, copy this down, plus in my parentheses I have 2 4/5 raised to the second power. Now I'm ready to continue on. Next I would take care of the exponent. Before I do that though, I want to turn this mixed number into an improper fraction. I do that by taking the constant out here to the front, the 2, multiplying it to the denominator in the fraction, and summing to that what's in the numerator. Then placing that value back over the original denominator. So this means that I will take this 2 and multiply it to the 5 to make a 10. I'll sum to that the 4 in the top to make 14. I then come back and put the original denominator in the bottom. Now I can recopy everything else down. Now I'm ready to take care of this exponent. I'm going to head and distribute this 2 into each of the positions inside the fraction. So that means that I have a 14 raised to the second power, or 14 times 14 to make 196. I then have a 5 raised to the second power. This then means 5 times 5 to make a 25. Continuing on from there, I'm now going to turn this division problem into a multiplication because I have fractions present. I keep the original value, the 4/5, as is. I turn the division sign to a multiplication sign, and then I take the reciprocal of the fraction that follows. That means I just simply flip it over. So I have 25 over 195. Next, I want to start combining these to find my final answer. Now, I have a couple of choices here. I'm going to bring this up. I have this 4/5 times this 25 over 195. I can choose to multiply across and then reduce, or I can choose to reduce beforehand. I'm going to reduce beforehand. I'm looking at a 4 and a 195. And first I want to see, does that entire 4 divide into 195? In this case, it does. It becomes 49. If it had not worked, however, I would look at the next largest number that would divide into this 4 and attempt to divide it into the 195. The 4 will go into the 4 one time, so I cross it out and make it a 1. The 1 across from it, the 195, the 4 goes into it 49 times, so I cross it out and leave the 49. Next, I look at the 5 to the 25. I know that 5 will go into 25 5 times. So I'll cross out the 5 and make it a 1. What I've done is divided that 5 by a 5 to make a 1. And I come up here and divide the 25 by 5. And this leaves me with a 5. I'm now ready to pull everything together. So in looking at this, what I created is the fraction 1 over 1 times 5 over 49. So I'm ready to multiply these together. 1 times 5 is 5. 1 times 49 is 49. I have my final answer. In question number 3, I find the indicated difference. That means that means to find the two values or two numbers subtracted from one another. It says to write your answer in a mixed number form and reduce if possible. Now with this number, there are two ways to approach this, and you were provided with two examples inside your modules page. Here, I'm going to show you the most common method. I have the 49 and 5/14 and the 30 and 7/10. What I'm going to do is break these apart into two pieces. I'm going to take the 49 and the 30 and set them up as a subtraction. So I have 49 minus 30, and this ends up equaling a 19. On the other side of it, I'll bring together the fractions. I have the 5/14 minus the 7/10. Before I can subtract these two, I need a common denominator. Between a 14 and a 10, that would be 70. If you weren't sure, you could start by setting up a list with the factors with your numbers until you come down to a common value. So, for example, I could start with 1 times 14 equals 14, and on the 10 side, 1 times 10 equals 10. I would continue to work my way down, 2 times 14, and then 3 times 14, and so on. What I'd end up finding out is that 70 would be their common denominator, so I'll put in a 70 here. Once I've done this, I need to write the equivalent fractions. So to get a 14 to a 70, I had to multiply by a 5. Whatever I did to the bottom, I did to the top. So this 5 also becomes multiplied by a 5 to make a 25. Coming over here on the 70, to get this 10 to a 70, I had to multiply it by a 7. So I multiply the top by 7. This creates a 49. Now, when I look at these, if I were to subtract these at this point, 25 minus 49, I would create a negative number. So that means that I need to increase this front number, and I'm going to borrow from the 19. I'm going to borrow 1 from the 19. Now I'm going to come up here just a little bit to the side and work with this. So when I borrow off the 19, what I'm leaving is an 18 out here. And on the 25 over the 70, I'm going to add that 1 to it. Well, a 1 in the same form as this fraction would be a 70 over 70. Any number divided by itself is 1. So 70 divided into 70 is 1. So I'm going to sum those two together, and I find that I have a 95 over a 70. On the other side, I still have my minus 49 over 70. So I'll carry that down, minus 49 over 70. So 95 minus 49 is going to leave me with a 46. So I have 46 over 70, and I still have my 18 out here. Now it told me to show it in reduced form, so I need to look at this 46 and this 70 and see if I can reduce them down. And I can. They're both divisible by 2, so I can divide a 2 in the top and the bottom. I have to make sure, however, whatever I divide one by, the other gets divided by the same to keep the equivalent fraction. So I'm going to divide this top by 2, I'm going to divide this bottom by 2, and I'll still have an equivalent fraction. So I'll keep the 18, divide the 46 in half, I get 23, then divide the 70 in half, I get a 35. So my final answer is 18, 23 over 35 with a fraction.